Sampling distributions of p-hat, like we did earlier with that customs example, give us all the possible p-hat values given a certain p-value. So if we knew the true proportion really was 70%, we want to find all the values that are acceptable from a simulation, or from reality, I guess. Now, to find a sampling distribution, so say we take a SRS of size n from a population, let p be the proportion of the sample. Then the mean of the sampling distribution of p hat will be exactly p. Like we found out earlier, the mean of that sampling distribution is what the proportion was. The standard deviation of the sampling distribution is something new. We take p times 1 minus p over n and square root it. Now a few notes. As the standard deviation gets smaller, the standard deviation gets smaller as the sample size gets bigger. We talked about that already. But since the square root is on the sample size, multiplying a sample size by 4 will cut the standard deviation in half. Multiplying the sample size by 9 will cut it in third. Multiplying by sample size by 16 will cut it in fourth, and so on and so on. But we have to know that the standard deviation formula doesn't always work. There's a couple things we need to keep in mind. First thing, the population has to be at least 10 times bigger than the sample. There's a reason for this, and it has to do with independence. We need each value to be independent, and if this is from a small population, each thing we take out changes the probability. I'll explain this better in class, I think, but keep in mind this is something that we have to show each time. Also, from our previous chapter, we have to check to see that there's a normal distribution, so we have to see that n times p and n times 1 minus p are both greater than 10. All right, good luck.